So we're going to move on a little bit. AP Calculus AB Intro to Riemann Sums Part 2. I'm going to start with this, and we agreed on this, and what we talked about last time is we said that we believe that as the number of rectangles goes to infinity, that we get an approximation of the area under a bounded curve. Well, it's not quite true, because the approximation, I guess, is just not good enough, or possibly it would be better to say that we can do better, because if we keep using rectangles like this, we're kind of saying that we're going to overestimate or underestimate one way or the other. So instead what we're going to do is just change some notation a little bit more and get a little bit closer to Riemann and say that as the width of the largest interval approaches 0. Now if the largest interval approaches 0, then all the other ones approach 0 also, don't they? So what we're really saying is that we're now trying to get bases, the base of our rectangle, to some number very, 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 very close to 0. So this is all we did to get this into Riemann's form, and we're saying that now we can agree that these are equivalents. So if we take this is equal to the indefinite integral. Oh, that's not true. The definite integral. Why is it definite? Because it's bounded. We're looking for the area between two places. A is the lower bound. The lower. B is the upper. So let's try this one. Let's try to evaluate this thing from -2 to 1. And I think that we can agree that -2 is less than 1. So we have a boundary set up. First thing we're going to do is we're going to try to come up with our change of x value. And our change of x is going to, this makes perfect sense to me. It bothers other people, but it makes perfect sense to me. If you have a line and you want to know how long your line is, then how would you find the length of this line, right? You'd subtract this, you take this number minus this one, wouldn't you? And that's all we're doing here. So let's find this. So b is 1 minus, and a is -1, so -2 all over n. So we know that our change of x is equal to this, and 1 minus -2 is 3, so is equal to our change in x. All right? So I think that makes really good sense. C sub I, our endpoint, is going to be a plus I change in x. And for us, that's going to equal, well, our a value, our lowest value, is just taking it here, right? Saying, what is this value? Well, we said, well, this is a, so -2, right? Plus, oh, this is I, not 2. This is I. So I, change of x is 3n, times 3n, so is equal to -2 plus 3i over n, right? Okay, now we are literally at fill in the blanks. So let's look at it, and we're going to say now that we believe this is true, that the definite integral is given by this. So the definite integral from -2 to 1 of 2x dx is equal to the limit as the largest base approaches 0 of the summation, as I equals 1, goes from 1 to n, of f of ci times change in x sub I. Remember, this is just a given endpoint, and this is a given base, because we're saying now that the bases might change and we need height. So this is just the area of a rectangle. Base times height is area, right? And we're going to take all those areas and we're going to add them together, and the accumulation of the area of all those rectangles will give us the area under the curve that we're interested in. I'm going to start filling in the blanks here, if you don't mind. And we're going to say the limit as n goes to infinity is equal to this. I'm sorry, it's not true. The limit is the summation I equals 1 to n of 2, right? Because it's 2x, isn't it? And x is -2 plus 3i over n, right? This 2, just to have it said, this 2 right here is because we want 2x. So let's look at this for a second. Just want to be clear about this. Right? This is where this is 2 times x, and we have 2x, right? And then, so this is the height times the base, and the base is 3n, isn't it? Okay? So this is what I'm going to do here. You know what I'm going to do here? I'm going to do this, I think. I'm going to see if you can follow this. This is kind of weird, but it's very, very doable. Just have to kind of get used to the weird thing. Again, we know our summation formulas, and they don't include n, so the best I can take n out, that's what I'm going to do. So I'm going to take out 6 over n. 3 times 2 is 6. This is 2 over 1, isn't it? N times 1 is n right there, right? And then we have times negative 2 plus 3I over n. Don't we? And then I guess I'm going to break this thing out a little bit more here. What I meant to do is have my summation in here. So I equals 1 to n. All right? I'm going to break this thing out a little bit here. Hold on 1 second. Okay, Avery needed me to tie her shoe. So now from here I'm going to try to go into summation formulas, right? And if you're not clear on what the summation formulas are, this is a great place to stop. To stop the video and go figure out what those summation formulas are and memorize them, because otherwise it's going to get crazy for you. So I'm going to do some summation here. Whoa, as n goes to infinity, I'm going to keep my 6 in here, right, times negative 2n, because if you put this in the summation formula, it's c times n, and c is negative 2, and negative 2 times n is this, right, plus 3n, and the summation formula for I is equal to n times n plus 1 all over 2. So that's how I got there. Now let's see what we get. Oh, look, this is going to work out good, I think. Let's see how this works out. There's tons of ways to do this, and I'm trying to figure out exactly how I want to do this. Yeah, that's what I'm going to do here. I'm going to go ahead and bring this thing in. Does that sound good? Let's try this. So if you're thinking, God, I wouldn't have done it that way, then seriously don't. It's cool. I'm just trying to think my way through it. There are tons of ways to do this right. The one thing is to try to be meticulous, and if you never hear this video, it's because I screwed up again and I wasn't being meticulous. So I'm hoping for good luck here. So here we go. We're going to get right negative 12 over negative 12n over n, right? Plus 18 over n squared, aren't we? Times n squared plus n. Oh, hell no, I'm not going to do that. See that? N times n plus 1 over 2. Stay with me a little bit, so I'm just going to keep cleaning this crap up. And remember, we're taking a limit, because this is going to make a ton of sense at the end why we're doing it this way. So if I do this, we get negative 12, don't we? 2 goes into itself once. 2 goes into 18 9 times. This ends up as, right, n, like that. Isn't that right? N over n squared is just like that, isn't it? And then what are we going to do? What are we going to do? Right, then we're going to send this in, and we're going to get 9n plus 9, right? I'm going to multiply this in here. So it's going to be plus, multiplying this to here and here. So plus 9n plus 9 over n. Look at this for a second. I'm going to keep cleaning this up as I go. 9n over n is just 9, isn't it? Plus 9 over n. That's this n right here. I brought it into here. Is that okay? And now, remember, we're taking this limit, and this is, I think, what people get freaked out about where they are. Is because before we worked, we said when n approaches 0, and people say, oh, it's not defined. It's totally defined here. What is the limit of negative 12 as n goes to infinity? Well, there is no value of n, so it doesn't change it. So it's negative 12. What's the value of 9 as n goes to infinity? Well, it stays 9. But what's the limit of 9 over this? So we're kind of saying, what is 9 over a huge number? We're saying some number that's close to, this is my approximation sign, almost equal to. If it's almost equal to that, 9 over an enormous number is about 0, isn't it? So we get this. And we get our answer is negative 3. Now, the next question we have to answer ourselves is, does this represent the area of the region that we're talking about? And I want to talk about that, but let's talk about that another time because I'm running out of time. Hopefully you have some of this figured out and it's getting better for you. Let me know.